Hi everyone, we are Group 6 and we will be presenting one of the most influential methods in lean construction, the last planner system. This system represents a fundamental shift in how we plan, coordinate, and execute construction projects. Over the next few minutes, we will walk you through what the last planner system is, why it was created, and how it helps teams deliver projects more predictably and efficiently. To begin, here's a quick look at what we'll cover today. This presentation will start with a brief introduction to lean construction, why it emerged, and the challenges that try to solve it. Then we'll explain what the last planner system actually is, outlining its core concepts and structure. We'll then move through its main components, see how it works in practice, discuss its benefits and common challenges, and finally look at a short case example before wrapping up with key takeaways and references. So let's begin by understanding the background. Why lean construction was developed in the first place? Construction has traditionally been one of the least predictable industries. We often see schedule overruns, cost increases, and wasted time or materials. Many of these problems come from how projects are planned. Decisions are made at the top, while the people doing the work have limited input. That separation causes uncertainty and misses coordination. Lean construction emerged to address these issues. It adapts lean manufacturing principles, particularly from the Toyota production system, to the construction environment. The goal is simple: reduce waste, improve flow, and maximize value for the client. Rather than treating each task as an isolated activity, lean construction views the project as a continuous production process where every step must support the next. And this is where the last planner system, or LPS, becomes essential. It's a structured yet collaborative approach that translates lean principles into daily planning practice on construction sites. The last planner system, or LPS, was developed in the 1990s by Glenn Ballard and Gert Howell. It's defined as a collaborative production planning and control system designed to make construction more predictable and reliable. The central idea is that plans are forecasts, but commitments are promises. In other words, we can create all the schedules we want, but they only have meaning when those performing the work commit to doing it. Unlike traditional push scheduling where work is assigned from above, LPS follows a pull system. Tasks are only scheduled when the necessary materials, information, and conditions are ready. The system has 5 connected planning levels: the master schedule or project plan, phase plan, look ahead plan, weekly work plan, and percent plan complete, or PPC, which measures the reliability or those commitments. In essence, the last planner system turns planning from a static document into a living, collaborative conversation that continuously improves project performance.
We're going to talk about the core components of the last planner system. Have you ever watched a trade foreman stare at a Gantt chart like it's written in ancient Greek? Today I'll show you the 4 Lego bricks, the core components of the last planner system, that turn the confusion into a promise the whole site can trust. What are the core components? The core components are not a fancy buzzword. They're the 4 non-negotiable moves you repeat every single week. Skip one and the plan wobbles like a Jenga tower when somebody pulls out the bottom row. Keep all 4 and the tower stands. even if the design changes or the steel truck is late. Now that we know the four bricks keep the tower standing, let's snap each one into place, starting with how we decide what should be built in the first place. Imagine you're handing over a finished job to the owner on some date. We pull that date backward: commissioning, finishes, MEP rough-in, drywall, slab, everything. Each trade now sees the hat off they must receive. No more, I thought you were starting Tuesday. This reverse dance is called pull planning, and it's the first brick. With the finish line mapped, we can immediately ask, can we actually run toward it? Time to open the 6-week radar. A rolling 6-week window acts like TSA security for tasks. No drawing, it's a red flag. No rebar, red flag. Each red flag is assigned to a named solver with a deadline. By the time the task hits the weekly promise board, it's pre-cleared for takeoff. Now once the runway is clear, it's promise day. The cushion shifts from can we to will we, and it's signed and sealed. Foremen move only the green tagged tasks into the sticky note board and literally sign their name. The signature is a promise to the crew, not to the project manager. The site goal is greater than equal to 70% PPC, percent promises complete. Hit that, and labor productivity jumps up to 20%. Promises made, work done, almost. We close the loop by asking, did we deliver? And why not if we didn't? 15-minute hurdles. What get what got done? Why did we miss the other 30%? The root cause on PDCA sheet, the plan, do, check, act sheet, which feeds straight back into next week's look ahead, closing the loop. This is where the Jenga tower gets its clue: continuous learning. The four bricks: should, can, will, did. Repeat them every week and your schedule stops being a wish list. It becomes a stack of promises your team can bank on. Now go build your tower, only one sticky note at a time.
So how does the last planner system work in practice? I will be going over how it works by using some general steps using the four core components and implementing a practical example of a builder wanting to build a building. So the first step is should. What should be done within the project? This is the main goals. In our practical example, a project manager and their team during this step would create a master schedule showing all of the major milestones. So this could be the design is complete by January 1st. Then the whole structure has been completed by September 1st. And then the handoff to the client on November. This is a rough example, and the milestones or timings are going to be different. So in the second step, we have can. What can be done within the project? It's where we would determine what is possible to do next based on constraints. So in our example, we have concrete needing to be poured next week. So we ask the question, can we pour the concrete next week? And the constraints are mapped. So the constraints would be like, is the rebar installed? Has all the formwork been brought up? Is the weather forecast looking acceptable in order to pour concrete? And for the third step, we have will, what will be done during the project. So different teams working on the project commit to deadlines for certain tasks during a weekly work plan meeting. In our practical example, we have the concrete team committing to having a slab poured on Tuesday, and then the electrical team commits to wiring zone 2 by the end of the week. The completion and progress of these commitments are tracked daily. And for our last step, we have a did, what was done during the project. This is where we measure the performance and learn from the outcomes. In our practical example, we look at if the commitments made during step 3 were completed. Did the concrete team pour on Tuesday? They did. Did the electrical team finish wiring zone 2? They did not. These are looked at by the end of the week, and then the PPC, or percent plan complete, is calculated. In our example, it's only 50%. During the step, we also look at the reason as to why things happened. So why did the concrete team pour, and why did the electric team not complete zone 2? These reasonings help create a more smooth workflow for the rest of the project or for any future projects. So now I'll go over some of the benefits of using the Last Planner system. So the Last Planner system provides projects with more reliability and predictability because teams working only plan for what's ready to be completed, and constraints with tasks are addressed early on so the roadblock can be removed and not cause any problems down the road. So another thing would be efficient workflow and less waste. Keeping with the same theme, by removing those roadblocks, less reworks of certain aspects of the project are needed, which keeps teams flowing smoothly, saving time, materials, and money. Because of this, teams are more productive, leading to smoother handoffs. Proactive planning also makes sure crews have no downtime, so their time isn't wasted. So two more benefits here. Because teams can make their own commitments, they can be more confident in the time it takes to execute, and openly collaborating with others can create a stronger sense of accountability. So one last benefit is the continuous learning and improvement of individuals and teams. By tracking commitments and performance, then reviewing those results, improvements are made week by week, ultimately leading to a smooth and successful project.
We're going to move on to identifying some challenges that you may expect when implementing Last Planner. The first one to note is that facilitation is important. Have you ever left a meeting and thought to yourself, wow, this could have just been an email? As there are many meetings, pool planning sessions, and daily huddles, if these aren't facilitated properly, they can feel like wasted time. The opportunity that Last Planner system gives with these sessions is only valuable if they're thoughtfully approached. Otherwise, those involved are going to get frustrated and apathetic, feeling like their time's wasted. On that note, the second challenge would be engagement. Without buy-in from everyone, the project's going to suffer, as Last Planner system is highly collaborative and relies on everyone's input and skills. Without buy-in and trust within the team, the quality of work and adherence to scheduling and solving problems as they arise can become painful. I'm going to read to you a quote from an article on the Last Planner system. This is taken from the Lean Construction Journal. One suggestion is that LPS facilitates the development of an environment with psychological safety, i.e., a shared belief that the trust-based team is safe for interpersonal risk-taking, and that teams operating under psychological safety become habituated and skilled in finding alternative ways to achieve goals in variable circumstances. So engaging project teams in such a way that they feel supported, trusted, and safe to share ideas and find solutions leads to more innovation as problem-solving opportunities arise. And as we know in construction, it has many variables and nothing ever goes just as we planned. Lastly, as we're placing more emphasis on the concept of the people who do the work plan the work, we need to strike a balance in the detail of planning. Too much and things get lost in translation and steps get missed. Too vague and specifications and goals may not be adhered to at all. That's why collaboration, diverse knowledge, and skills on teams is important to Last Planner. We need the right details for our audience, as well as the right amount of detail for what we want to accomplish. Okay, let's move on to a quick case study on the Last Planner system in use. The Sky Center 1 was completed by J.E. Dunn Construction in 2021, and it's a 9-story office building at the Tampa Airport in Florida. It houses offices, a parking garage, a cafe, a fitness center, and it connects to the train. The Last Planner system was utilized in the design phase. So the design of the foundations using Last Planner system were able to be completed ahead of schedule by 2 months. And this in turn allowed construction to start 2 months ahead with the deep foundations. While this was happening, trades were being sequenced in such a way that work was always getting done on site. The team utilized constraint and commitment logs at each weekly meeting. These helped keep the focus of the meetings to task and needed scheduling and who was responsible during each task phase, and therefore everyone was accountable to their piece of the project. This ensured that the project continually stayed on track and without delay, as due to the frequency of the meetings, with clear goals that were attached to them, illuminated what was needing attention and who would be responsible for attending to them. The success of implementing the Last Planner system in this project actually created space for the project owner to design the cafe area themselves as construction continued to progress. As a result of this implementation, the project overall was completed 2 months ahead of schedule.
So up to this point, we've looked at it, what the Last Planner system is, what makes it unique, and how it's actually used on site. To sum it up again, LPS is, just like the name says, a system that's built around the people who are actually doing the work. It's not some top-down management tool. It's grounded in the field with the people who make things happen. Think of it like the engine of a car. It's where lean construction really starts to move. Because it's so connected to the real work, it helps us predict what's going to happen more accurately. And when things are more predictable, people trust each other more and they trust the process more too. That trust leads to better collaboration, and better collaboration makes things even more predictable. It's a cycle. And the cycle leads to less waste and better productivity. What's great is that LPS is an open system. It gets adjusted and improved based on feedback from the field, daily, weekly, whatever the rhythm is. That openness is actually one of the core values of lean construction, being flexible and always improving. And because of that, LPS connects really well with other lean tools and systems like Big Room, integrated project delivery, value streaming, mapping, A3 problem solving, and Beam. Let me show you how they all fit together. Earlier, I said LPS is like the engine. Then the big room and IPD, you can think of them as the engine bay under the hood. That's where all the decisions like master schedules, weekly work plans get made. Big room is the space where collaboration happens. LPS is the plan that gets executed inside that space. And IPD is the structure that supports that collaboration. LPS brings IPD to life by making it part of the daily routine. Now, what about value streaming mapping? VSM helps us see the whole process flow and spot waste. So it's kind of like the dashboard in a car. It shows us what's going on. LPS takes that big picture and turns it into daily actionable promises on site. VSM draws the map, LPS drives the route. And if something goes wrong, well, just like a car needs maintenance, we need a way to fix things. That's where A3 problem solving comes in. It helps us define the problem, analyze it, and improve it. So if a plan fails or a promise isn't kept, we can use A3 to figure out why and make it better. And all of this, it gets even stronger with BEAM, Building Information Modeling. As you know, BEAM tools keep evolving. They help us build a shared ecosystem for collaboration. With BEAM, all the info is in one place, and LPS use that info to actually make things happen on site. It's like the connection between an ECU and a center monitor in the cabin. Data flows back and forth to guide the system. So what do you think? For us, Group 6, it was interesting how all these systems come together to shape lean construction. And among them, LPS isn't just about making plans, it's about making promises and process that can actually be kept.